question number 24 says, it gives us the equation, which I've drawn in purple here. So the graph of 6 sine x cos cube plus 6 sine cube cos x minus 3 is shown here. And it's asking us to determine that the function y equals a sine bx plus d. So basically, they are the transformation. So we're going back to chapter 1. Chapter 5. So we have our vertical expansion or amplitude. We have our b, which is our horizontal compression, and we have d as our vertical shift. So we can establish what a is here, because the a value, if we take a look at the amplitude, we can see that the amplitude is going to be 3. So the a value must be equal 3. So top to bottom is going to be 6, so the amplitude is 3. So I'm going to start writing this in. So y is equal to 3 sine. So now to determine b, we need to figure out what the horizontal compression is. So what I've done is I've just taken two arbitrary points, and again we need to graph this to be able to find some good points, but there are some very good points in here. I've done this in radians. You could do this in degrees as well, but I've done it in radians, and I have from pi over 4 or 45 degrees to 5 pi over 4 or 125 degrees, and the period in this case, I'm just going to bring this line down, the period t is equal to pi. Okay, so that means there's a horizontal compression of 2. So this becomes 2x. So there's my horizontal compression. And then we just have to get the vertical shift. The vertical shift is going to be based on this center line here, the line of symmetry. And we can see that it's been shifted down 3. So it's going to be minus 3. And so by looking at the function and some key parts of the function, we can relate it back to this general form of our sine function here.